Hello guys. So hey guys. In this video, I'll be reading Mycelium running book from Paul Stamets. So if you know Paul, he's the pioneer in um, AI world. Okay. So what what my goal from this book is that I'm a person psychologist. I wanna learn as much as I can books. So without further ado, get started. Okay, right. First chapter is the mycelial mind, part one. Okay, now let's go. There are more species of fungi, bacteria, and protozoa in a single scoop of soil than there are species of plants and vertebrate animals in all of North America. And of these, fungi are the grand recyclers of our planet. The magicians, assembling large organic molecules into simpler forms, which in turn nourish other members of the ecological community. Fungi are the interface organisms between life and death. Look, look under any log, look under any log lying on the ground. You will see fuzzy cobweb like growths called mycelium, a fine web of cells which, in one phase of its life cycle, fruits mushrooms. This fine web of cells courses through virtually all habitats, like mycelial tsunamis, unlocking nutrient sources stored in plants and other organisms building soil. The activities of mycelium help heal and steer ecosystems on their evolutionary path, cycling nutrients through the food chain as land masses and mountain ranges from successive generations of plants and animals are born life. And fungi are keynote keystone species that create ever thickening layers of soil which allow future plant and animal generations to flourish. Without fungi, all ecosystems would fail. With each footstep on a lawn, field, or forest floor, we walk upon these vast sentient cellular membranes. Fine cottony tufts of mycelium channel nutrients from great distances to fast-growing mushrooms. Mycelium, constantly on the move, can travel across landscapes up to several inches a day to weave a living network over the land. But mycelium benefits our environment far beyond simply producing mushrooms for our consumption. Humans collaborate with these cellular networks using fungi, specifically using mycelium as spawn. For both short and long-term benefits, mushroom spawn lets us recycle garden waste, wood, and yard debris, thereby creating mycological membranes that heal habitats suffering from poor nutrition, stress, and toxic waste. In this sense, mushrooms emerge as environmental guardians in a time critical to our mutual evolutionary survival. I believe random selection is no longer the dominant form of human evolution. Our political, economic, and biotechnological policies define our future. For better or worse, some forecasts claim that half of the current is here in the next 100 years. If current trends continue, what if Pentagon report issued in October 2003 an abrupt climate change in our conditions for United States national security? Swords and Randall 2003 hypothesizes that a more dire and imminent collapse of our biosphere may occur as climates radically destabilize as a result of pollution and global warming. I wonder what would happen if there were a united organization of organisms, UOO, pronounced UOO, where each species get one note. Would we be voted off the planet? The answer is pretty clear. When we responsibly exploit the earth, disease, famine, and ecological collapse result, we face the possibility of being rejected by the biosphere as a virulent organism. But if we act as a responsible species, nature will not evade our fungal friend, equip us with tools to act responsibly and repair our shared environment, leading the way to habitat recovery. Knowing how to work with fungi by custom pairing fungal species plant communities critical for our survival. 21st century may be remembered as the biotech age when these kinds of mycotechnology play a prominent and increasing role in habitat mycotech. Chapter 1, Mycelium as Nature's Internet. I believe that mycelium is the neurological network of nature, interlacing mosaics of mycelium infused habitats with information sharing membranes. These membranes are aware, react to change, and collectively have the long term health of the lost environment. The mycelium stays in constant molecular communication with the environment, devising diverse enzymatic and chemical responses to complex challenges. These networks not only survive but sometimes expand to thousands of acres size, achieving the greatest mass of any individual organisms on this planet. That mycelia can spread enormous cellular mats across thousands of acres in a testimonial to a successful and versatile evolution. The history of fungal network. Animals are closely related to fungi than to any other thing. More than 600 million years ago, we shared a common ancestry. Fungi evolved a means of externally digesting food by secreting acids and enzymes into their immediate environments and then absorbing nutrients using net-like cell chains. Fungi marched onto land more than a billion years ago. Many fungi partnered with plants, which largely locked these digestive juices. Mycologists believe that this alliance allowed plants to inhabit land around 700 million years ago. Many millions of years later, one evolutionary branch of fungi led to the development of animals. The branch of fungi leading to animals evolved to capture nutrients by surrounding their food with cellular cells. Essentially, primitive stomachs as species emerged from aquatic habitats. Organisms adopted means to prevent moisture loss in terrestrial creatures. Skin composed of many layers of cells emerged as a barrier against infection, taking a different evolutionary path. The mycelium retained its net-like form of interweaving chains of cells and went underground, forming a vast food web on which life flourished. About 250 million years ago, at the boundary of Permian and Triassic periods, a catastrophe wiped out 90% of the Earth's species when, according to some scientists, a meteorite struck. Tidal waves, lava flows, hot gases, and winds of more than 1,000 miles per hour caused the planet. The Earth dark Earth darkened under a dust cloud of airborne debris, causing massive extinctions of plants and animals. Fungi, in, fungi inherited the earth, surging to recycle the post-cataclysmic debris fields. The era of dinosaurs began and then ended 850 million years later. Another meteoritic hit, causing a second massive extinction. Once again, fungi surged, and many symbiotically partnered with plants for survival. The classic cap and stem mushrooms, so common today, are the variants that predated catastrophic events. The oldest known mushroom, based in amber and collection in New Jersey, dates from Cretaceous time, 92 to 94 million years ago. Mushrooms evolved their basic form well before the most ancient mammal ancestors. Mycelium steers the course, of ecosystems by favoring successions of species. Ultimately, mycelium prepares its immediate environment for its mate by growing ecosystems that fuel its food chain. Eco, Eco James Lovelock, together with Lynn Margulis, came up with the Gaia hypothesis, which postulated that the planet's biosphere intelligently piloted its course to sustain and breed new life. I see mycelium as the living network that manifests the natural intelligence imagined by Gaia theorists. The mycelium is an exposed sentient membrane, aware and responsive to changes in its environment. As hikers, deer, or insects walk across these sensitive filamentous nets, they leave impressions, and mycelia sense and respond to these moments. Complex and resourceful structure for sharing information. Mycelium can adapt and evolve through the ever-changing forces of nature. Okay, so got figure 1. The mycelial network is composed of a membrane of interweaving, continuously branching cell chains, only one cell wall thick. This is mycelium. Okay. We have figure A. Evolutionary branches of life. Animals have a more common ancestry with fungi than with any other kingdom, diverging about 650 million years ago. A new super kingdom, Opisthocomata, has been erected to encompass the kingdoms fungi and animalia under this one taxonomic 2005. Okay, fungi, animals, mycologia. Figure to the journal Mycologia featured this 15 to 20 million years old amber with a mushroom embedded, now called Orofungus canigensis, dating from Miocene time and collected in the Dominican Republic. The oldest mushrooms in amber are estimated at 94 million years ago. Figure 3 micrograph of astrocytic brain cells networking of neurons created pathways for disturbing information. Mycelial nets share the same architecture. Figure 4. A diagram of the overlapping information sharing systems that comprise the internet. Figure B and C. Oxalic acid, calcium oxalate. Oxalic acid, calcium oxalate. Oxalic acid crystals are formed by the mycelia of many fungi. Oxalic acid mineralizes rock by combining with calcium and many other minerals to form oxalates. In this case, calcium oxalate sequesters two carbon dioxide molecules, carbon-rich mushroom mycelia pull into complex food webs, crumbling rocks as they grow, creating dynamic soils that support diverse populations of organisms. Below, scanning electron micrograph of calcium oxalate mycelium. This is a electron micrograph of mycelial network. It's quite interesting. Calcium oxalates. Figure D. Prototexites was the name given to this fossil, a remnant of a life form approximately 420 million years old, existing at the end of the late Silurian and through the beginning of the Devonian periods, found in Canada and Saudi Arabia. These organisms was widespread across the landscapes of the Paleozoic era. First described in 1859, the fossil remained a mystery till C. Kevin Boyce and others proved that it was a giant fungus in 2007. Figure artist depiction of prototextile, which was the tallest known organism then in its time, laying down or standing upright, the tallest plants feature next to prototext sites were less than a meter high. I I especially feel that this is true upon entering a forest or a rainfall, and I believe that blessing mycelial membrane is awakened. This sensitive mycelial membrane act as a collective focal conscious. As mycelius metabolisms surge, they emit attractants, parting sweet fragrances, forest and air species. Like a matrix, a biomolecular superhighway, the mycelium is in constant dialogue with its environment, reacting to and governing the flow of essential nutrients, cycling the food. I believe that the mycelium operates at a level of complexity that exceeds the computing powers of our most advanced supercomputers. I see the mycelium as the Earth's natural internet consciousness with which we might be able to communicate through cross-species interfacing. We may one day exchange information and cellular because these externalized neurological nets sense any impression upon them. From footsteps to falling tree branches, they could relay enormous amounts of data regarding the movement of all organisms through the landscape. A new pioneering science could be born dedicated to forming mycological networks to mycelial webs could be used as information platforms for microengineered. Now we have a figure 5 here, a slime mold Physerum polysperm choose the shortest route between two food sources in a maze, disregarding dead ends. Controversial article proposes that this computer model of the early universe, these primeval filaments basis and ciliar archetype. 7. Computer model of dark matter conject of string theory. More than 96% of the universe is comprised to composed of these molecular threads. Note that galaxies interspersed throughout the life matter. Figure 8. Cultures of this yet to be named Californian psilocybe mushroom swirl like a cyclone as outward of growth. Figure 9. Several mycelial mass of the root for Mycelium mushroom spiral outward, killing a forest in. Once these trees dies, they become highly inflammable. See also figure 60 for a larger patch of Armillaria, the largest organisms in the world. The idea that a cellular organisms can demonstrate intelligence seems radical, not for work by researchers like Toshiyuki Nagasaki. It placed a maze over a petri dish filled with the nutrients agar and nutritious food flakes at an entrance and exit. He then inoculated the entrance with a culture of the flying mold Physerum polycephalum under sterile conditions. As it grew to the maze, it constantly chose the shortest route to the oat flakes at the end, rejecting dead ends and empty exits, demonstrating a form of intelligence according to Nakagami and his fellow researchers. This is true, then the neural nets of microbes and mycelia may be deeply intelligent. A few recent studies support this novel perspective. Life can be intelligent, may have potential as our allies. Perhaps being programmed to collect environmental data as suggested above, or to communicate with silicon chips in a computer interface and fungi as nanoconductors in microcomputers Coleman and his fellow researchers at Northwestern University have manipulated mycelia of Aspergillus niger to organize cold into its DNA, by creating mycelial conductors of electrical potentials. NASA reports that microbiologists at the University of Kansas, led by Gary Taylor, have developed a drug biological computer chip housing bacteria that glow upon chance. Miller 2004. Such innovations hint at new microbiotechnology, the near horizon. Fungal networks, environmentally responsive bacteria to provide us with data about pH, detect nutrients, and even measure biological. Fungi in outer space. Fungi may not be unique to Earth. Scientists theorize that life is spread throughout the cosmos, that it is likely to exist wherever water is found in a liquid state. Recently, scientists detected a distant planet 5,600 light years away, which formed 13 billion years ago, old enough that life could have evolved there and come several times over. Took 4 billion years for life to evolve on Earth. Thus far, 120 planets outside our solar system have been discovered, and more are being discovered every few months. Astrobiologists believe that the precursors of DNA, free nucleic acids, are forming throughout the cosmos, inevitable consequences of matter as it organizes, and I have little doubt that we will eventually survey planets for mycological community. The fact that NASA has established the Astrobiological Institute and that Cambridge University Press has established the International Journal of Astrobiology, strong support for the theory that life springs from matter and is likely widely distributed throughout the galaxies. I predict an interplanetary journal of astromycology will emerge as fungi are discovered in other planets. It is possible that proto-germplasm could travel throughout the galactic expanses, riding upon comets or carried by stellar events. This form of interstellar protobiological migration, known as panspermia, does not sound as far-fetched today as it did when first proposed by Sir Fred Doyle and Chandra Wickramangal. In the early 1970s, NASA considered the possibility of using fungi for interplanetary colonizations. Now that we have landed rovers on Mars, NASA takes seriously that unknown consequences that our microbes will have on steering other planets. Force have no borders. Hurricane Isabella approaches North America in October 2000. At mycelial archetype, figure 11, spiral galaxies conform to the same Earth typical pattern as hurricanes and mycelium. Nature tends to build upon its successes. The mycelial archetype can be seen throughout the universe. The patterns of hurricanes, dark matter, and the internet. The similarity in the form informed to mycelium may not be merely a coincidence. Biological systems are influenced by the laws of physics. It may be that mycelium exploits that natural momentum of matter, just like salmon takes advantage of the tide. The architecture of mycelium resembles patterns predicted in string theory, and astrophysicists theorize that the most energy conserving forms in the universe will be organized as threads of matter energy. The arrangement of these strings resembles the architecture of mycelium. When the internet was designed, its web-like structure maximized the pooling of data and computational power while minimizing critical points upon which the system is dependent. I believe that the structure of the internet is simply an archetypal form, the inevitable consequence of a previously proven evolutionary model, which is also seen in the human brain. Diagrams of computer network semblance to both mycelium and neurological ability in the mammalian brain. Figures Right? Figure 3, and this is the mycelial network and neurons and brain in our neuron. Right? Our our understanding of information networks in their many forms will lead to a quantum leap in human computational power. Mycelium is the web of life. An evolutionary strategy mycelial architecture is amazing. One cell wall thick, in direct contact with myriad hostile organisms, yet to pervasive that a single cubic inch of topsoil contains enough fungal cells to stretch more than 8 miles of place end to end. Figure 12, close up of mycelium. This is how network. I calculate that every footstep I take impacts more than 300 miles of my. I These fungal fabrics run through the top few inches of virtually all land masses that support life, sharing the soil with legions of other organisms. If you were a tiny organism in a forest soil, you would be enmeshed in a carnival of activity with mycelium constantly moving through subterranean landscapes like cellular waves, through dancing bacteria and swimming protozoa with nematodes racing like whales through a microcosmic sea of life. Year-round, fungi decompose and recycle plant debris, filter microbes and sediments from runoff, and restore soil. In the end, life-sustaining soil is created from debris, particularly dead wood, and now time when microfilters of select mushrooms can be constructed to destroy toxic waste and prevent disease, such as infection from coliform or staph bacteria and protozoa and plagues caused by disease carrying organisms. In the near future, we can orchestrate selected mushroom species to manage species questions. While mycelium nourishes plants, mushrooms themselves are nourishment for worms, insects, mammals, bacteria, and other parasitic fungi. I believe that the occurrence and decomposition of a mushroom predetermines the nature and composition of downstream populations in its niche. Wherever a catastrophe creates a field of debris, whether from downed trees or an oil spill, many fungi respond with waves of mycelium. This adaptive ability reflects the rooted ancestry and diversity, resulting in the evolution of a whole kingdom populated with 1 to million species. Fungi outnumber plants at a ratio of at least 6 to 1. About 10% of fungi are what we call mushrooms, and only about 10% of the mushroom species have been identified, meaning that our taxonomic knowledge of mushrooms is exceeded by our ignorance by at least one order of magnitude. The surprising diversity of fungi is the complexity needed for a healthy environment. What has been become increasingly clear to mycologists is that protecting the health of the environment is directly related to our understanding of the roles of its complex populations. Our bodies and our environments are habitats with immune systems. Fungi are a common bridge between the two. All habitats depend directly on fungal allies, without which life support system of the earth would soon collapse. Mycelial networks hold so together and radiate them. Fungal enzymes, acids, and antibiotics dramatically affect the conditions and structure of soil. In the wake of catastrophe, fungal diversity helps restore devastated habitats. Evolutionary trends lead to increased biodiversity. However, due to human activities, we are losing many species before we can even identify them. In fact, as we lose species, we are experiencing devolution, turning back the clock on biodiversity, which is a slippery slope toward massive ecological collapse. The interconnectedness of life is an obvious proof that we at our path. In the 1960s, the concept of better living through chemistry became the ideal as plastics, alloys, pesticides, fungicides, and petrochemicals were born in the laboratory. These synthetics were released in they often had a dramatic and initially desirable effect on their targets. However, events in the past few decades have shown that many of these inventions were in fact the fruits of science, leaving a heavy toll on the biosphere. We have now learned that we must tread softly on the web of life, or else it will unravel beneath. Toxic fungicides like methyl bromide and once touted not only harm targeted, also non-targeted food chains threaten the ozone layer. Toxic insecticides often confer a temporary solution until tolerance is achieved. When the natural benefits of fungi have been repressed, the perceived need for artificial fertilizers is creating a cycle of chemical ultimately eroding sustainability. However, we can create mycological sustainable environments by introducing plant partnering fungi, mycorrhizal and prophytic combination with mulching with saprophytic mushroom mycelia. The results of these fungal activities include healthy soil, biodynamic communities, and endless cycles of renewal. Every cycle, soil depth increases and the capacity of biodiversity is enhanced. Living in harmony with our natural environment is key to our health as individuals and as a species. We are a reflection of the environment that has given us birth. Strongly destroying our life support ecosystems is tantamount to suicide. Enlisting fungi as allies, we can offset the environmental damage inflicted by humans by accelerating organic decomposition, massive fields of debris through everything from clear cutting forests, constructing cities. Our relatively sudden rise as a destructive species stressing fungal recycling. The cascade of toxins, debris generated by humans destabilizes nutrient return cycles, causing crop failure, global warming, climate change, and in a worst case scenario, weakening the pace towards eco catastrophes of our own making. And ecological disruptors, humans challenge the immune systems of our environment beyond their limits. The rule of nature is that when a species exceeds the carrying capacity of its host environment, its food chains collapse and disease emerge to devastate organisms. I believe we can come into balance with using my regulate the flow of nutrients. Age of mycological medicine. Now is the time to ensure the future of our planet and our species. Partnering or running